All right, here's an exponential question that has a couple of things that make it even more challenging than regular exponentials. So it's very similar to the one that I was asked about by an Algebra 2 student who's in a really challenging math class. So I get it. And this is just like one of the early problems in this section. So these are tough. Okay. So if a radioactive substance is decaying, that's a key word right there. Decaying at a rate of 8.5% per hour, 8.5%. Approximately how much of a 300-pound sample remains after 1 day? Okay. So we have hours and days. That's important that we notice. When you're setting these up, you always set your starting amount first. So 300 is where it starts. And then you want to think about the percentage next. All right, so here we go. We're going to look at this 8.5%. So we have to think about that as a decimal. And now if you want, if you need a refresher on this, because it's not 0.85%, it's different. And so you can look up there for that little video to see like how to change those to decimals. But 8.5% is going to be 0.085 as a decimal. You move the decimal back 2 places. That's one way to do it. There's several ways to think through it. Okay, so if this is 0.085 and it's decaying, that means it's decreasing, getting smaller, getting lower, right? And so this is always 300 times 1 plus or minus. Well, it's minus because it's decay. That makes sense. The 0.085, and it's raised to the t power, which is time. So I think this is a really good time, a good moment to put this on the screen and say, and it's covered up with my writing. Let's see if I can move it over. This is when we have this tendency to think, I'm so dumb. Like, this is too hard. I cannot get this, right? I mean, I know that for me, my brain goes there pretty quickly when I'm struggling and frustrated and something seems like it's Greek. Like, that doesn't even, like if you're looking at that and you're like, I don't understand any of this. Take a deep breath, right? And I'm talking to myself as much as you, and think, I'm learning. I need more practice with this, but it's okay that I don't know it right now. That doesn't mean I'm dumb. It just means I haven't practiced it enough, right? I haven't had time to really work on the problem and figure this out. So taking a deep breath. All right, let's keep going with this. All right, so let's talk about that a little bit more and just kind of make sure we're clear. So this part always stays the same. When you're looking at equations like this, you've got the amount at the beginning, you've got a 1, and you've got a plus or a minus, the percent, but you have to write it as a decimal, and it's always raised to the t power. Okay, so plus or minus. We know that it's minus because it's decay. Decay is getting smaller. That makes sense. So we're going to use some good logic with this. We know the amount was 300. That's what it starts at. And so then the percent as a decimal, that's the 0.085. That's the part that if you are not clear on why 8.5% equals 0.085, then you need to watch that video and just get a refresher on that. And then it's raised to the t power. T stands for time, which is great because that makes sense, right? T is the first letter in time. So if the time here is 1 day, but they're telling us the rate is per hour, then think about why it makes sense that T here is 24. Because it's 8.5% for every 1 hour, but we're saying not after 1 hour, but after 24 hours in a row, right? After one whole day. 1 day equals 24 hours. So that's where the 24 comes from. All right. So let's go to handy dandy calculator. Okay. So I'm just going to see what is 1 minus 0.085. It's 0.915. So really here I have 300 times 0.915 raised to the 24th power. And so I'm going to type that in, 300 times 91. I hit delete and it erased everything. I was trying to use my keyboard. Let me try that again. 100 times. If you knew how my day was going, you would be like, oh, yeah, this makes perfect sense. Of course, you can't type anything into a calculator right now. But we have to laugh because it's okay. It'll be fine. We'll get there. All right. Now I think I've got it. 300 times 0.915 times to the 24th per power. Enter. And we get this crazy number. Okay. Now, 35.58, blah, 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 blah. Let me slide this back out of the way. All right. I had on here and I don't see it now. So I've deleted it somehow. Imagine that. We're going to go to the 10th place, round to the nearest 10th. So this would be about 35.6 because 0.58 is going to round to 0.6. Pounds. It started out as pounds. It ends as pounds. So after one day, that 300-pound sample, this rock, whatever it is that we're looking at, is down to 35 pounds in weight. That's crazy. That's so crazy. And that's exponential decay. Exponential decay it rapidly descends or it rapidly grows if it's exponential growth. So that was a long explanation. This video is way longer than it had to be. I'm thankful that you stuck with me through it. All right. Remember, don't let anyone think less of you because you're young. Have a great day.